Horseshoe crabs, you probably know them. Those amazing living fossils, right? Ancient creatures that look like they haven't changed much in ages.
That's a popular image, yeah.
But, for the longest time, there was this massive, almost baffling blank spot in their early story, a huge evolutionary gap.
A really huge gap. We're talking about 80 million years missing from the fossil record.
80 million? Wow.
Yeah, between the very earliest known Ordovician species and then the more familiar ones, the Zephosyrida from the late Devonian period.
So trying to connect the dots was difficult.
Incredibly difficult. Like, imagine trying to understand a family tree with generations just missing. Made tracing their origins, their early diversification, really tough.
Okay, let's unpack this. But the exciting part is now. Well, now things have changed, right? There's been a discovery.
Exactly. A discovery fully described and named in 2025 that's finally starting to bridge that enormous gap.
So today we're doing a deep dive into Circulimulus discobulus. This is a Silurian horseshoe crab, and it's apparently rewriting the book on these incredible arthropods.
It really is offering a fascinating new chapter.
Our mission today, understand how this one ancient creature helps connect 80 million years of evolution. Let's get into it. So who is this Circulimulus?
Well, the specimen itself isn't actually brand new. It was found way back in 1975.
Oh, really? 1975?
Yeah, by Samuel J. Circa. Found in Indiana, in the Kokomo member of the Wabash Formation.
So it sat around for a while.
It seems so, yeah. Its full significance wasn't really appreciated until James Lamsdale formally described and named it Circulimulus discobulus in 2025.
Discobulus. Does that mean something?
It does. It refers to its shape kind of like a discus, that throwing disc. Apparently the body shape is quite striking.
Huh. So you picture this ancient thing, maybe huge, but it's not.
No, actually, it's remarkably small. The fossil is only about 44.8 millimeters long, just under 2 inches.
Tiny, but the key is its age, right?
Precisely. That's what makes it so significant. It dates to the Silurian period, specifically the Upper Ludlow age. We're talking roughly 424 million years ago.
And boom, there's the gap filler.
Exactly. It slots right into that 80 million year void. It connects those really early forms, like Lunataspis from the Ordovician,
Right.
with the later groups that led towards modern horseshoe crabs. And, just for clarity, when we say Zephosyrida, we mean the whole group, living and extinct. Zephosyrida is the more specific lineage, including today's horseshoe crab.
Okay, got it. So this Circulimulus, you said it's described as really primitive.
Extremely primitive for a Zephosyrida, yes. But crucially, it also shares features with the later forms. That's why it's such a good link.
So it's like finding the original design, the basic plan.
That's a great way to put it. Phylogenetically looking at its evolutionary relationships, it comes out as a sister taxon to the Zephosyrida.
Meaning, like a very close cousin that branched off just before the main group we know today.
Exactly. So it gives us these vital clues about the ancestral ground plan for all horseshoe crabs that followed.
Okay, like what specifically? What primitive features does it show us?
Well, one big thing is its post-abdomen, the back part of the body. It's multi-segmented, meaning the segments could move freely.
Ah, unlike modern ones.
Right. Later Zephosyrida, including the ones alive today, tend to have that rear section fused into a single piece, the opistosoma. Circulimulus shows the ancestral state was more flexible.
Interesting. Anything else about that ancestral plan?
Yeah, it also tells us the ancestor likely had a semicircular thorastron, that's the middle body section, and two distinct freely moving segments connecting that midsection to the head shield, the prosoma.
So really painting a picture of a more segmented ancestor, but it wasn't just primitive, right? Did it have its own unique features?
Oh, absolutely. It wasn't just a simple ancestor. It had its own specializations. The most distinctive one is probably its telson.
A tail spike.
Yeah, that long spike in the back. In Circulimulus, it's bifurcated. It splits at the end into two short prongs. That's unique to this genus.
Huh. A two-pronged tail spike, that's different. And how did they even see all this detail on a tiny ancient fossil?
Well, that's where modern tech comes in. Techniques like laser-stimulated fluorescence were used. It basically makes fine details glow, even if the preservation isn't perfect.
That's cool. So this detailed look, it also tells us something about extinction, doesn't it?
It does, and it's quite profound. The existence of Circulimulus in the Silurian suggests the huge End-Ordovician mass extinction event. Well, it didn't wipe out the early horseshoe crab lineages as much as perhaps previously thought.
So they were pretty resilient.
It seems so. These non-icephager types, these more primitive forms, persisted. It implies the big diversification, the radiation of the Zephosyrida group that leads to modern forms, probably happened later, maybe in the Silurian or the Devonian.
Okay, that's a really big takeaway. It shifts the timeline for their main evolutionary burst. So for you listening, what's the bigger picture here?
I think it highlights a couple of things. First, the resilience of life, obviously,
Yeah.
but also the fact that these early forms hung on into the Silurian and that this specific fossil was found in Laurentia, that's ancient North America.
Right.
It points to this region possibly being a really important center for early horseshoe crab evolution. It dramatically reshapes how we see the when and where of key steps in this ancient lineage.
So from this 80 million year enigma to this crucial connecting piece, Circulimulus really is a bridge across time. It reminds us that even so-called living fossils have these really complex, surprising evolutionary stories behind them.
Absolutely. And connecting it even broader, it just underscores how vital every single fossil discovery can be. Even a small, unassuming one can completely rewrite our understanding of life's history and its incredible ability to endure.
It definitely makes you think what other secrets are hiding, maybe in plain sight in a museum drawer, or still locked away in the rocks just waiting,
Yeah.
waiting for a new technique or just someone looking with fresh eyes. Definitely something to keep exploring.